Now we are going to discuss, after the experimental setup, we have what are the effects due to this experimental setup, how we can use this experimental setup. That is first one, effect of intensity of incident light on photoelectric current. Effect in the sense, what type of effect? Effect of intensity of incident light I am talking about. Intensity of incident light, how it affects the photoelectric current. Let us see. For example, the UV light I have shown in the previous case. When the UV light is incidenting on the metallic plate, then if intensity of light is more, then therefore automatically the amount of photoelectric current which is develops in the circuit is more. This is when there is a condition applied. For the fixed frequency of photoelectric current, if it is increases with the intensity of light. If there is no fixed frequency, then it may change, it may affect. That's why the condition is that it must be fixed frequency from the source. Then intensity of incident light, if it is increases, then photocurrent will increase linearly. The second effect you can find, effect of potential on photoelectric current. How potential will affect on photoelectric current? See, we have created potential by using the battery from outside. We have a rheostat also, voltage and ammeter also is there. Then how this potential effect comes, let us see. For example, if you take the potential in the experiment, I can use a battery by using the rheostat. I can increase or decrease the potential. Is there possibility? Yes, it is a possible thing because I'm using the battery from their external source. I have created the potential difference between the anode and cathode. So what I'm going to do now, effect of potential. I have a chance to increase the potential of anode. Means if I'll increase positive potential, what happens? If I'll increase positive potential, whatever the electrons are coming, the electrons gets attracted and electrons energy will increase automatically. It gets faster attraction takes place towards the anode. Due to that, photoelectric current increases due to increasing the anode potential. But if you decrease the anode potential, what happens? If you decrease anode potential, electrons not attracted quickly by the anode. If you decrease further below the negative, then anode is acting like a repellent for the electrons. Then that time how photoelectric current changes. If you decrease anode potential further below the zero negative direction, then obviously the anode is acting as a repellent for the electron which is delivered or emitted from the metallic plate of cathode. So the electron may not reach the anode. Therefore, by that, what happens? It will not contribute for the photoelectric current. The electron drop in the middle itself. So, in such case, what happens? Here, what are the conditions we should follow? First, whether frequency is fixed or intensity of incident light is fixed. We should know it. You are seeing the potential. If I'll increase further the anode, how much you increase the potential, the photo current remains constant after certain extent. See, I have taken two cases, L1 and L2 are the two different intensity of incident lights. Both cases, the photo current increase, though how much you are increasing the anode potential, that much only the photoelectric current can come. That is a saturation point for the constant intensity of incident light, as well as for the fixed frequency. Here two things are constant, intensity of incident light as well as for the fixed frequency. The photocurrent reaches saturation point though you are increasing the potential of anode further. The next point you can see here, negative region. If I could decrease the anode potential, if I could decrease the anode potential, then what happens? The negativity will increase on the anode. So the electrons will not contribute the photoelectric current that time. So it goes into negative, it decreases. Some electrons may drop out also. Okay, this point will not be zero within the positive region. It is going towards a negative region. Of course, this is depends on the metallic plate also, where the point, the potential became zero, though we are decreasing the potential. Then at what point the photoelectric current is zero? That point we call it as zero potential, or we can call it is as a stopping potential. What it is? Stopping potential. When the potential is decreased, the current decreases, but current is decreasing, but not zero at this point. It is zero at a particular potential point, where the potential becoming zero, that point we call it as zero potential, or also called as stopping potential. Most important thing is that stopping potential. This is saturation current. This is a second effect. Ah, this stopping potential is also called as cutoff potential, we can call it as. With respect to anode and cathode, this potential we call it as cutoff potential or stopping potential. This is the second most important effect. Next, here intensity of incident light does not affect this stopping potential. Remember, I kept constant frequency and intensity of incident light. Okay, but though I kept constant, if you see the intensity of incident light, that is independent of stopping potential. Remember, the wordings are most important in this effect. Saturation current means what? Stopping potential or cutoff potential means what? We should be clear about that. Now, you can see effect of frequency of incident light on photoelectric current. Till now we have seen potential effect and intensity of incident light when the frequencies are constant. Now we are going to see effect of frequency of incident light on photoelectric current. How frequency affects? Simple is that. Here we are going to see for a fixed intensity of incident light. Here we are keeping intensity of incident light is fixed. Okay, then the photoelectric current does not depend on the frequency of the incident light. Always remember, for a fixed intensity of incident light, the photoelectric current will not depend on the frequency of incident light. Means both are independent. Because the photoelectric current simply depends on the number of photoelectrons per unit second emitted from the metallic plate. Why? Photoelectric current always depends on the number of photoelectrons which are emitting from the metallic plate. The number of photons incident and not on the energy of photons. If more number of photoelectrons are emitted, then easily that is depends on the intensity of incident light. It is not depends on the energy. Frequency means what? Frequency means energy of photon increases, but intensity of incident light is depends on the number of photoelectrons. If intensity of incident light increases, number of photoelectrons which are emitting out from the metallic plate will increase. It may not helps for the energy of photon. Energy of photon comes due to only frequency of light, remember. The fourth effect, effect of frequency of incident light on stopping potential. We discussed in previous case, intensity of incident light is independent on stopping potential. But here, effect of frequency of light on stopping potential. Frequency affects the stopping potential. Let us see. As we know that the potential along The x-axis anode potential as well as cathode potential, means anode potential in negative direction, photoelectric current. This is in this we are going to see for different frequencies what is the stopping potential. In previous case we have seen for constant frequency you have seen. In this, for example, I have taken some 100 Hz frequency of a light which is incident on a metallic plate, and I got saturation point as well as stopping potential. The stopping potential I got at this point. Look at here on the screen. Okay, this is the stopping potential of 100 Hz frequency. If I'm increasing the intensity of incident light frequency 100 to 500 Hz, then what happen? My stopping potential from this position to this position, it has changed. But the saturation point of photoelectric current remains constant. Who is affecting? Only stopping potentials are affecting. Okay. So here frequency of which light is more, that stopping potential is greater. Simple as that. Means from this we can understand frequency affect the stopping potential. Okay. But different frequencies of light, different stopping potentials are available. See, for a fixed intensity of light is constant here. Photocurrent increases, it reaches the saturation point. But if you change the frequency of light, the stopping potential also changes. This is the fourth effect from the photoelectric effect. Here, stopping potential always directly proportional to the frequency of light. Remember, if you change the frequency of light, stopping potential changes. This is the fourth effect on the, from the photoelectric effect. Now, fifth one, threshold frequency. Entire photoelectric effect, this is the most important effect. Threshold frequency, you can mention here one more threshold wavelength also. Since source from the source frequency is the most important, so we will take it into terms of frequency. Threshold frequency means optimum frequency, the frequency which is required to emit the electrons from the metallic plate is called as threshold frequency. For example, in photoelectric effect, for all the lights we have seen in the previous class, for all the lights, the metallic plate will not emit the electrons. For UV light, it emits. For example, normal visible light, if you expose on normal metals, it will not emit any light. But same normal light, if it is exposed or if it is projected on the alkali metals, it emits the electrons. Means what is the relation? For alkali metals, whatever the visible light is we are projecting, that visible light is having the suitable frequency for alkali metals. But for normal metals, it is not the suitable frequency. We need more frequency to emit out. So the required frequency which allowed to emit the electrons from the metal plate, means here there is one more concept comes into the picture called as work function. Work function is belonging to the metals. Work function in the sense the amount of energy required to remove the electron from the metal plate is called as work function. If more the work function, then more the emission takes place. You can see here, if I am increasing the frequency, the stopping potential will increase. But it is not increasing from the point of origin after certain point. What is this region? This region we can consider as a threshold frequency or optimum frequency. Okay, so you can find it's linear increasing after optimum frequency with respect to the stopping potential. Okay, so it depends on the nature of the materials always, I said. Nature of the materials. These are the most important effects which we need to know from the photoelectric experimental setup. One is threshold frequency with respect to the stopping potential. The other one is that effect of frequency of light with respect to stopping potential. One more thing, the frequency is independent of the incident light. And second thing, the effect of potential on photoelectric current when frequency and intensity of incident lights are constants. And the first one is effect of intensity of incident light with photoelectric current that is linearly both since they are proportional for fixed frequency. These are all effects from the experimental setup of photoelectric effect. Further, from this, we can classify and we can try to understand more analysis from the basic data of these experimental effects. Thank you.